Hello and welcome to our lesson 3.6. We're going to deal with a different way of looking at the spread of data. The information here is something called a normal distribution or a bell curve, and it's based off of the mean rather than the median being the middle. And then we count what's called standard deviation amounts to the left or right or above or below. And through that, we can capture percents of the data. You want to have this written down. So the first standard deviation away from the mean accounts for 34%, both left and right. So a total of 68% of the data is within one standard deviation. And then two standard deviations, it's going to be a total of 95% of the data. Okay, if we go a little bit further, there'll be, you can add them up. It's 99% is within three standard deviations, and a standard deviation is going to be these points right here. So whatever our mean is, we'll do a problem to kind of give you some of the detail there. But the percents you're going to want to keep track of, and then the middle is going to be the mean in this case, and then we're counting rather than 25% at a time. Each of the percents are different depending on how far from the mean we are. So how do we know if this is normal? Basically, when you look at it, it looks symmetric and bell-shaped, okay? Most of the data should be between, we're going to say 95% of the data should be between plus or minus 2 standard deviations. So if you go up 2 and down 2 and add up those percents, you get 95, and we're going to say that's most of the data. So let's go through an example here. The weight of a newborn baby approximates a normal distribution with a mean of 7.3. So we can label on our bell curve some of the information here. This is 7.3 pounds. And each standard deviation is worth the same amount, 0.8 pounds. So if we add 0.8 or subtract 0.8, we're going to get the following. If we add, we're at 8.1. If we add another, it's 8.9. Add another 9.7 pounds. If we go down to this side, subtracting 0.8 from 7.3, 6.5, 5.7, and then 4.9 pounds. So you can say, if we talk about where does most of the data lie, it lies between 5.7 and 8.9. So looking at some of these questions, most newborns are between 5.7 and 8.9 pounds. A baby that weighs 8.9 pounds is how many standard deviations from the mean? Well, it's 2 standard deviations, and that's above 2 standard deviations above the mean. All right, let's do a quick review and do some compare and contrast of last lesson where we dealt with box and whisker. And I thought this was a good classwork that we could talk about some of the ways to do some problem solving when we're trying to identify. We can kind of do some elimination, hopefully starting with what we think is easiest or most obvious. So when we look at skews, generally the skews are the easiest to see. And you'll notice when we get into some of these examples, the skew of this one is to the left. That's where the data is mostly to the right, but the extreme values are to the left. So that's the skew. So this is a left skew, and that's what this box plot identifies. Likewise, if we look here, right skew is going to have the extreme values on the right. These three are going to be representing these three histograms, and they're kind of difficult. Hopefully the middle one here, the one that's got most data, the middle over here, the most of the data is really concentrated in the middle, and it's causing the IQR to be narrower, so it's less spread out. And we're going to call that a good match for H and A. And then these two are really kind of challenging. The D and the B, they're both somewhat, they're obviously symmetric, but this one's got a lot more data spread out evenly, and this one's really got the data spread out on the edges with not much happening there. So this spread here is going to show up greater on the box plot, and it matches with I. Likewise, this one is pretty uniform. If you look here, the whiskers are definitely out on the similar sizes, whereas this one, most of the data is going to be out on the edges. And so we would say this one matches. J and D match. Okay, that's kind of challenging. These last two I think are difficult. Hopefully the skews and the nice bell curve and its box plot makes some sense. And then finally, when we look at this, the double box and whisker plot represents the test scores for your class and your friend's class. So if we were to look at these box and whiskers, identify the shape of each. Hopefully you look at this and see a little bit of a skew to the left. And then likewise, this one pretty much looks uniform or normal. Which test scores are more spread out? So if you look at these going from the min to the max, and as well the IQR, the box, you can see that the friends class has a greater range and IQR. Moving on. Considering the three graphs shown to the right, these are normal curves. Which graphs have the same mean? The mean is going to be, again, the middle. And if you look here, the blue and the black both have a mean right through whatever value this is. We don't even need to see the value, but we know that their means are the same, even though their spreads are different. Which groups have the same standard deviation? Again, that's measure of spread. So the bell curve looks the same, and that's going to be for B and C. Which graph has the greatest mean? The mean is going to be this value right in the middle, and the green one, or C, has the greatest mean. And then which graph has the greatest standard deviation or the most spread? And we would say that that's A. Moving on, last little problem here before you're able to get into the homework, I think, or we're going to do some classwork stuff in this video. The double box and whisker plot represents the battery lives of two brands of cell phones. Identify the shape of each distribution. Well, if you look at this one, it looks roughly uniform. We're going to say that's a normal curve. This one, mostly because of this one's pretty close to normal also, but since the median is in the middle, remember again, box plots look at the median as the middle, 50% are to the left and 50% are to the right. For this one, we would say that it's slightly right skewed. It's not a lot. All right, so what is the range of the upper 75% of each brand? That means the lower 25% is going to be on the left, the upper 75 is to the right. So when we look at that spread, we'd see that A is 3.5. It goes from 3.5 up to 7, and the B goes from somewhere between 3 and 3.5 up to somewhere between 5.5 and 6, and that's got a range of 2.5 between the Q1 up to the maximum. Shouldn't use the word range there. Compare the interquartile ranges, the IQR, that's going to be the boxes. Compare those two. Both have roughly the same IQR. Which brand do you think has a greater standard deviation? And we want to explain it. Remember, standard deviation is measuring our spread. A is more spread out if you go from the min to the max, even though the IQRs are similar. And then finally, you need a cell phone that has a battery life of more than 3.5 hours most of the time. Which brand should you choose and why? So we're looking for 3.5 hours. If we look at the percents here, remember this is interquartile, and so each is a quarter here in the box plus the whisker. So that's 325s or 75. And then for B, it really starts at the median, so only 50% is above. So we would choose A for battery life that's likely to last longer. All right. Looking at some classwork here. For each problem, draw and label the mean and 3 standard deviations on a normal curve. The weight of snapping turtles is normally distributed. One of the things we want to start with is being able to draw what that bell curve would look like. So every bell curve has this basic shape to it. One standard deviation is at 40. So we have the mean here, and then 1, 2, and I'm just going to cut off 2 standard deviations for now. So it says here that 1 standard deviation above is 40. So that's this spot here, and this is the mean, right in the middle. And then 1 standard deviation below is at 30. And we know that they're going to be equal distance. The standard deviation is the same. So if it's a total of 10, that means there's 5 and 5. So our mean is 35 pounds. The weights of apples in a crate are normally distributed. You know that a crate that weighs 130 grams is 1 standard deviation. Well, I'm going to jump in right away to drawing my bell curve. All right. And then this is going to be my mean right in the middle there. It says the weight of apples, you know the crate weighs 130 if it's 1 standard deviation above. So this guy again is 130. Another crate that weighs 150 is 2 standard deviations above. So now this is 150. If you look there, it looks like it's 20 units, 20 pounds that between each standard deviation. If I keep going to the right, I'd be adding 20. To go to the left or make it smaller, I would subtract 20. So let's see here. Identify the mean and standard deviation. So the mean is going to be 110. The standard deviation was 20 pounds. How many grams? Oh, we're talking grams here, not pounds, I guess. Anyway, grams would a crate weigh if it was 2 standard deviations below the mean. So we're going to go 2 standard deviations below, 1, 2. If each standard deviation is 20, looks like grams. I should read my word problem better. If I go 2 standard deviations, that's a total of 40 less than 110. That puts this at 70 grams. And then finally, looking at these box plots, it says for each paired data displays, determine the following. What's their shape, which has a larger mean, and these are going to be, estimates, which has a larger standard deviation or spread. Okay, so looking at these, we're going to want to identify spread and mean. And we're just going to be comparing for problem 3, set A versus set B. So we're just comparing 2 graphs and stating what their shape is, as well as means and standard deviation. So this one is roughly symmetric or normal. We'll call it symmetric for now. And then what do you think this one is? Take a moment and try to say what it is. It's not extreme, but this one we would say is right skewed. And then finally, where would the mean be for this one? Looks like it's going to be maybe a little bit bigger than 4. This one's clearly got most values 3 or less. So this one's going to have a greater mean. And then these are kind of lumped together. This one tends to be a little more spread out. So we'd say this one probably has a larger standard deviation. Now comparing these, try to take that first part here and see if you can make some assumptions and then check your answer. You can hit pause and see how you would do. Okay. On this one, we're going to say this one is right skew. And then this one, even though there's quite a bit of kind of normal looking here, these we're going to say are right skewed. You could argue maybe it's normal, but we're going to say they're both right skewed. And then this one, the mean is going to be more down in this area here, whereas this mean is closer to 4. So this one's going to have a greater mean. And then this one, these extreme or more extreme values are going to cause a greater standard deviation. Okay, and again, this one here, it's negotiable. We're going to go with the right skew. You could argue possibly normal. Finally, we're looking at box plots again. Remember, there's 25% between each of the values in the 5-number summary. This top one here, again, it's somewhat slight, but it's a right skew. And this one, we're going to say, is more of a left skew. And looking at where is the data as far as finding a mean. This mean, we don't know, again, this is median here, but it looks like there's more of the data going to be in this area. This one has a bit of a spread up there, but we're going to go with the mean on this one is slightly larger. And then this one, definitely from the min to the max, has a greater or larger standard deviation. Okay. All right. So based on this, hopefully it looks like material that's not too easy, but with some thought, it's starting to sink in. We'll see you in class.